Hello and welcome. In previous video, we discussed about binary search trees and even we have written a sample program to create node and a class for tree as well. So the same example, let us try to debug it to see how it traverses through each node in the binary search tree. Before going to that, let's see what exactly is a binary search tree. Let's recall the definition. Binary search tree is a special kind of binary tree where every node follows two rules. Number one is the left child is always less than the parent node, and number two, the right child is always greater than the parent node. This particularly this feature allows faster search, insertion, deletion with the average time O of log n. So think of it as a sorted tree that helps us find values within the tree quickly, just like binary search. So let's start with the previous program that we had. So I just copied from the previous one. We have the class tree node with the init method assigning data left right to the node, and we have definition in order traversal, and we have the steps, and we are creating root and other nodes, and we are making root left right. Likewise to the children nodes, we are making left and right nodes. And finally, we are trying to traverse through the tree which prints all the values that we have created as part of the tree. Right? Let's start debugging. Here we are using an editor called Cursor, so which has AI enabled chat. We can find if there is any issues during the debugging. So to start debugging, click on this icon and look for this Python debugger, debug Python file. Click on it. You will be able to see in the terminal saying that bsd.py execution has a command that started, and in the left sidebar you will see variables, locals and globals. Initially no one, so it started defining the class. So just go to next. It goes to the first step of the execution root equal to tree node 13. So it creates node 13 after this completes. Let's pass this. So it went into tree node call init method self.data equal to data. Here it is 13, and 13 got assigned to data. If you see left, right, and goes to next method. Now let's see, data is 13, left is none, right is none for root node. Let's pass this. It creates a tree node, node 7. Data is 7, left none, right none. So now we have, after node, we have node 7 with data 7 and left as none, right as none. Let's go to root. It is same because we have not yet assigned right and left. We will be doing in the later steps. So let's pass this. Next is 15. So we are creating each independent node. So node 15 is created. Now node 3. Node 3 is created. node 8, root, node 8 is also created, 14, node 14 is created, 19, node 19 is also created, 18. Now all the nodes have been successfully created as individuals. So now if you see, for every node, left and right will be nones. So now what we have to do? We have to assign root left and right. So if you pass this, if you open root node, you can see left has been assigned with node 7. Let's expand and see. So data 7, left and right, none. Let's pass. So right also assigned with 15. Now node 7 left becomes node 7 has got left, that is 3, and right becomes, you see, right becomes 8. So for 15, you open 15. Now left is none, right is none. After this step successfully completes, left becomes 14 and right becomes 14. Let us check this here. Left is 14, which is correct, and right is 19. Likewise, node 19 left becomes node 18. So now we are calling Inorder traversal of root. Root is nothing but the node that we have created with 13. We are passing the root as an object parameter to Inorder traversal. Let's go to next. So Inorder traversal, it has taken node. So node value is root, that is 13, that has 7 and 15 as left and right. Even if you can see, we are passing 13 means it has all its children's till the bottom of the tree. So we can traverse through all the elements by passing just root into Inorder traversal. So if node is none, node is not none, so it went to next step, and again we are calling node Inorder traversal node dot left. Left is nothing but 7. We are passing 7. It has to go here. So 7 has come here and now into node, and it is checking whether it is none or not. It is passed. It went to next step. So 7 left becomes 3. It's the node has become 3, which is not none. It goes to the next step, node left, and 3's left is none. So node is none. Node is none, it returns. So it has to come to return as expected. So return will go back to here. So in here means it is node value 3. So it will traverse back there where node is 3. You will see node as 3 and prints 3. So we got the output into terminal here, 3 with the ending comma and space for having the spacing in between the sequence of tree values. So then next it goes back to no dot right. For 3 there is no right, so it returns back to 7 and prints 7, and no dot right. So no dot right is nothing but 8 in our case. So no dot left. For 8 it is left is none. So returns and prints 8. So if you see in our previous videos, there we have represented this as a tree. So it is easily understandable. 3 has no children and 8 also has no children, so it went back. Now no dot right is none, returns and prints 13. It has came back to root. Now traverses to right part of the tree. So roots right is not none, 15. So it checks for 15's left and it is not none. As it is none, it comes back and prints 14 and checks for 15's right, which is none, and prints 15. Again checks if it is none. So 19 has value 18 and 18 has left as none, so it prints 18. Again it calls right, which is none, returns and prints 19. So at last the Inorder traversal is complete. You have got all the elements. So this is how binary search tree traversal happens. Even when we are searching for a particular element, we can put a condition. As we have node is none, we can put a condition saying node dot data is equal to value to search, then return found and print the value. So that is how we can do binary search tree traversal. So finally we got to see the sorted output of the values we have provided in the console here. So let's recall the points for binary search trees. Binary search trees are efficient for searching, inserting and deleting values. And we have explored node creation and searching. Traversal and BST are used in many real-world applications like databases, compilers and file systems. If you found this video helpful, give this video a thumbs up and subscribe for more content, and watch other videos for Python DSA topics. Got questions or you want anything else to cover? Please drop a comment below. Thanks for watching. See you in the next video.